Bearings is a method of determining direction, all relative to a fixed direction, this being north. So whenever we want to go from one point to another, we'll say, okay, well, what bearing is this second from the first? We'll look at the north line, the line going straight up from, in this case, A, and saying, if we were to go clockwise from this north line, how far we have to go, how many degrees until we hit the line heading towards B. It always has to be clockwise, and it's always relative to north. And both of these have to always be the case because it's the standardization. That's how we know what it is regardless of where we are. If you just told someone that they were 100 degrees clockwise from where you were, or 100 degrees to the right or something, if they don't know that's relative to north, that's not necessarily going to be very helpful. We need to have this relative starting point and this known way around. With this in mind, if you're going to be measuring a bearing of something, you are going to need this, which is A. Now, how we then use this protractor is we're going to take this crosshair a little bit in the middle, and we're going to line it up with the point you're measuring the angle around. And then the 0 line, this line that would be 0 on this scale here and 180 on this scale here. It may be inverted on your protractor there, but made slightly differently. Will go on the north line. The main thing is the actual semicircle of the protractor is then on the right-hand side because, again, this angle here will be going clockwise. So if we just want to try to line this up here as best we can. So our 0 line is on the north, this crosshair is on A, and if we now read around on the inside axis, because that's the one starting at 0, you want to make sure you're starting from 0. We're going to go around, and that lines up on 115 degrees. So that's going to be our bearing of B from A. So there's A here, B from A. The one you're measuring around is the right-hand letter, the second one, what you're going from. The one you're then going to is the first one, so B from A. If, however, we wanted the bearing of A from B, so we're now focusing on B, yet again, we have to go clockwise. So we'll have to start going around this way. I'm going to keep going, until, yeah, now we've hit the line. Now you have a couple of options here. Either we could look at what this angle on the left is going to be, the anti-clockwise angle. Obviously this isn't the bearing, but because these two then would make a full circle going a full way around the point B, they would add up to 360. These two lines, then because they're both north lines, we know they're parallel, they're in the same direction, two angles between parallel lines with a diagonal going through them, they add up to 180. So if this is 115 here, this would have to be 65 degrees, leaving this here being 295. Alternatively though, if we still want to use the protractor, we can line this up with B. So, and we'll notice, okay, we're going around. Oh, well, we need to go further than this. That's currently stopping at 180. This is where, therefore, we will now flip that protractor as I have just done here. We know that at this point that was 180 degrees, so we'll now just continue reading again on this inside scale. Now, in our example, this will just come from me not drawing a perfectly straight line. We can see here from the north line, that's not going exactly straight up, so this won't be exactly straight either. But it's going to be close enough on 115. On yours, you would be able to draw this exactly with a ruler. Yeah, so if that's now 115 degrees, beyond 180, add them together, that's going to be 195 again. So again, that's just confirming that would be the bearing of A from B. And that's, yeah, that is the crux of bearings. It's just, okay, what point are we going from which point to which point? What would be the north line? So just going straight up. and then measure an angle going clockwise from that. If you have enough numbers and straight lines, you can just do it mathematically, like using angles between parallel lines, or you use your protractor and measure it by hand. You have to be careful if you are measuring it in the question, whether or not it says it's been drawn to scale or drawn accurately. If it's not been drawn accurately, you will have to use algebra and the equations on the page. With that in mind though, let's see how you do now with an example. If we just create a couple another of points, so let's say we've got a point A here and a point B here. Now you were told that there was actually a third point, a point C. Now C from A has a bearing of 120 degrees. And then C from B has a bearing of 210 degrees. Obviously, you may want to replicate this on a piece of paper for yourself with a protractor. Just try to find where would C be. Mark this with an X, and then just draw your lines connecting up A and C to make it a triangle, and B and C to make a triangle. And then once you've done that, just first of all, plot C. Then work out what is B from C. Pause the video, work this out for yourself, and then when you're ready, press play again and compare. Alright, so if C from B is going to be 210, that's going to be going beyond the 180 mark. So we're going to be going all the way around here, and now having to flip that protractor around, as it is currently now. If the total is 210, and we've already gone 180, that leaves us with 30 degrees still to go. So if we'll find 30 on this inner track here, okay, and that's going to be around here. With then just a flip of the protractor, we can now move it over to A to measure from here. So if that's at 120 degrees, we'll read that off again from the inner scale on this protractor. That's going to end up being here. At this point, once you've made these two marks, you're going to just want to move the protractor out of the way. And then from here, if we were just to draw two lines again, you on your actual paper, you can use a ruler. We'll just create straight lines. We'll just create two straight lines going from B through the point we made for the bearing of 210. And we'll make another line here from A going through the point for 120. This point here, where the two lines cross, that is the point where if we had measured from our north lines, that would be 120, and this would be 210. This is where C is going to lie. Now then, in terms of the measuring what B is from C, you could just create your north line and then get out your protractor again and measure. So we'll get that protractor, move it over here, line it up as best we can. This here, as you can see, like I haven't been able to draw a perfect straight line, but that looks as though if we compare against B, this will be at the 30 degree mark. So this bearing looks as though it should be 30 degrees. If we're happy with that, we can now move on to an actual exam paper question. Here we are given a triangle base ABC, where the line AB has been extended upwards as a north line. We are told that length AB is 6 kilometers and that length BC is 4.5 kilometers. This is in a right-angled triangle, to be clear. And it asks you to calculate the bearing of C from A. If we're going from A, then our bearing is going to be going from A, its north line, going clockwise around until we hit this line heading towards C. Here we're told though that this diagram is not drawn accurately. We can't use the protractor this time. We will have to work this out using more algebraic mathematical methods. Considering what we have to work with, therefore, what this is, again, a right angle triangle, where we know the two sides, and we may wish to work out what this angle here is. Because we know if we're just finding the bearing from B from A, that's going to be 180 degrees, because it's straight down. So if we can just work out what this extra angle here is, add that onto the 180, that will give us this whole bearing here. Well, what topic uses right angle triangles, sides and angles? That would be trigonometry. If we're thinking about SOHCAHTOA, therefore, we might as well label our sides. This here, AC, would be our hypotenuse because it's the longest side, it's the one not touching the right angle. This AB here, the 6, that is our adjacent because that's the other one touching the angle we're measuring here, and that leaves BC being the opposite. This question, therefore, we have information about the opposite and the adjacent, so we'll be using tan. Tan of our unknown angle theta would equal 4.5 over 6. To get the angle, though, just the theta, you'll do the inverse of the tan. If you're not entirely happy with this trigonometry, I would suggest you look at that video in particular, just to make sure you're all apprised for when you get to other questions that cross over with it, such as this one. So tan inverse of that same 4.5 over 6. And let's say it's to the nearest degree. So here, even though it's not a final answer, we might as well already round to a nearest whole degree. That's going to be 37 degrees. Adding this on then to the 180, that will give us an ultimate bearing of 217 degrees.